This is lesson 10 in Algebra 1, division by zero, exchange of factors and multiplication, and conversions of area. Alright, division by zero. Pretty straightforward. Any number with a zero in the denominator does not exist. It has no meaning, it has no value, so when you get something like this, you just write it as undefined. There isn't an answer. It's not zero because zero is a number. It exists. So this one is undefined. Whenever you have a number in the top, though, that's a zero, the answer is always zero. So it doesn't matter what's on the bottom, the answer is zero. It doesn't matter what's on the top, the answer is always undefined. So that's the section on division by zeros. Let's jump to the exchange of factors in multiplication. What that really means, exchange of factors in multiplication, is shown in example 10.2. We have negative 4 times 3 times negative 6 times negative 2. Alright, so what that means is you can multiply these numbers in any stinking order you want to multiply. And usually there's a way to do this that's easier than others. So you may do something like, let's get our numbers back here. You may do something like 2 times 6 is 12, times 3 is 36, and that's like 36 times 4, I don't know what that is. Or you may do 4 times 3 is 12, times 2 is 24, times 6, don't know what that is. But 4 times 3 is 12, times 6 is 72, and then I double that and get 144. So there are some ways to multiply where you're going to get an answer easy and some that are going to be more difficult. So what I like to do, if I'm multiplying a whole stinking slew of numbers like this, I like to just multiply the numbers, then count the negative signs. And if there's an odd number of negatives, your answer is negative. If there's an even number of negatives, your answer is positive. So then you don't have to fight with, well, is it negative or positive? Negative 4 times 3 is negative 12. Just trying to figure out all the negatives and positives. It's easier just to do the multiplication and stick the negative on there at the end. All right, so let's look at example 10 point, let's see, 10.3 and 10.4 are the exact same. They just shifted the numbers around on us. So let's jump up to, let's just do this one. Negative 6 times 2 times 3 times negative 3. Alright, so 6 times 2 is 12, times 3 is 36, times 3, don't know. 3 times 6 is 18. Times 2 is 36. 36 times 3, I don't know that one off the top of my head. So maybe there really isn't a way that's one way is going to be easier. So you just pick one. 6 times 2 is 12. And 12, so that's going to give me 12. And then 3 times 3 is 9. And 12 by 9, or 12 times 9 is, I know that's 108. And just because I know my multiplication table is up through 12, and I have two negative symbols, and that is an even number, so my answer is a positive 108. Alright, so jumping to, get rid of all this, jumping to conversions of area. Okay, so we have done other conversions. So this time we're going to be doing conversions of area, which means we're going to start out with 44 square inches, and we're going to try to change that to square centimeters. Alright, so if you remember how to do this, you take your 44 inches squared, make a multiplication sign, make a line, and put inches there. Alright, problem is, we have 2 inches here, and we only have 1 there, and in order for us to cancel, we have to have 2. So we're going to put another one in here. So now we have 2. So whatever we put up here, we're going to put up here. So we're just making 2 of the exact same thing. So do we know a comparison between inches and centimeters? Well, that comparison is 1 inch equals 2.54 centimeters. So I do know that comparison. So 1 inch is 2.54 centimeters. 1 inch So we just did it twice, and we had to do it twice because we have it twice here. Okay, so we're going to cancel these 2 inches with these 2. We're left with centimeters here, so I know I'm done. So now I just multiply, put that over 1, multiply 44 times 2.54 times 2.54, and the book just lets you leave the answer like this because they're assuming that you can take a calculator out and multiply that. So what's the point of just doing all the work? Okay, well let's look at, come on, get rid of all these. Let's look at example 10.6. We're converting 125 centimeters squared, but this time we're converting that to feet squared. So we're going to write 125 centimeters squared times line centimeters times line centimeters. So whenever this is squared, we're going to have this show up twice. If this were cubed, if we were looking for volume, this would show up 3 times. But anyway, so just for squared. So we're going to see if we can compare centimeters to feet. I have no idea what the conversion is there. But I do know centimeters to inches. I do know that there's 2.54 centimeters in 1 inch. So I'm going to write that twice. Then I can cancel these 2 centimeters with that one. And what I'm left with is inches. Is inches what I'm looking for? No. So I keep going. And again, I have to do 2. Every time I draw these now, because I'm dealing with square centimeters and square feet, I have to put it down there twice. So I'm going to put the inches twice on bottom since they're showing up twice on top. And I do know that there's 12 inches in 1 foot. And I know that therefore I can cancel that and that with that, and I'm left with feet, which is exactly what I want to be left with because that's what I'm looking for. And I multiply the top, 12, and then 125, and then that multiplies by 1, by 1, by 1, by 1, so nothing happens. And that's going to be over 2.54 times 2.54 times 12 times 12. And that's going to be our answer there. And that's feet squared. Okay, that's it for lesson number 10.